Hello, and welcome to today's webinar. My name is Magnus Hedley, and I'm working for Trimble Solutions, and I'm based here in Sandvika in Norway. Today's webinar will be about new technology to reduce CO2 emissions from road and railway projects. So the agenda, I will start a little bit with the industry challenges today. We will a short look on the traditional planning methods, and we will spend the most of the time looking up on Quantm and the algorithm behind the software, finding optimal corridors with as low CO2 emission as possible. So we have the global carbon law, which means we should reduce 50% CO2 emissions every 10th year. So by 2050, we should be climate neutral. Especially here in the Nordic countries in Scandinavia, there is set quite tough requirements due to CO2. Nye Veier, Statens vegvesen, Trafikkverket, Bane Norway have almost the same goals to reduce with about 40% before 2030. So the challenges you are facing when you are planning infrastructure project is sometimes it can take long planning time. A lot of projects are going over budget. Research has also shown 60% of CO2 comes from the transport sector. There's also quite often conflicts and discussions between different stakeholders, between the owner, designer, the community. And very often we have environmental and sensitive areas that we should try to avoid. So in Trimble, we are working with our Quantm with different kind of software. Probably you have seen this slide before. We are Quadra in the middle, the BIM platform, and we have different Trimble software around the Quantm. We can also add more software and software from other vendors, from Autodesk and Bentley as well. Just one slide from the webinar yesterday about Tilos, which is also a planning software, time location diagram with distance and time. We can draw activities. Here we have an environmental restriction in this area at this time. We have to jump over, work on the other side, and bring our equipment back and work here later. So with Tilos, it's also possible to have diagrams and work quite detailed with CO2. This was yesterday. So today we will focus on the first software in the Quantm, Quantm, which is a strategical tool in early phase, feasibility phase, to find the optimal corridor. So this is just a picture from a project up in Norway, where we can see that the dark blue cheapest alignments form an obvious corridor. We can also work with CO2 estimates from building the road, and also CO2 estimates for the future emission from different cars driving on the road. Which means we can compare hundreds of different alternatives due to cost, but also consider the CO2 emissions to build it and future use. So with Quantm, the basic is that you add different constraints, terrain model, the design criteria, CO2 and costs. Create a project inside Quantm, and the algorithm will calculate the optimal corridors, and by that you will reduce your planning time. You can test different options, scenarios, compare different speed limits. What is also great is that you can document for the owner why you have chosen this path or this route and not another corridor. You can also optimize alignments inside of a corridor, work with the cost and CO2 from the very first beginning, and the output from Quantm will be the input to your design. For example, take the alignments from Quantm and take it into Quadria Nova Point. So when is the optimal time to use Quantm? My opinion, I will say in the early phase, feasibility phase, the scooping. But you can also take alignments from a design tool into Quantm to see the cost, CO2, and also do further optimization. This slide shows different stakeholders and different people that are involved in a Quantm project. We need somebody who knows costs, environment and CO2, geology specialists, GIS people, project management can take decisions, and we also need the design criteria. So starting with the design criteria for the project I'm going to show you now, we have a railway, 220 kilometers an hour. We have set the cost and CO2 parameter. This is a standard template, but you can also define different cost and CO2 parameters or adjust the template. And it's a double high-speed railway. So we add the terrain model. We have some height curves, the auto photo on top of those. We can add local GIS data, telling where it's cities, buildings, water, different GIS. Then we have to say about the geometry, speed limits, and those kind of things. If there are any points we have to avoid or pass through between the start and end point. So when you have added all this information, Quantm will in one single analyze return you multiple of alignments, hundreds of alignments in different colors, where the blue one shows us the ones with lowest cost and CO2. So we can documentate, we are not going on the right side of this lake, but we have one corridor here in the middle. We can see this is about 10 million, but Quantm is also good to define a corridor, and also you can see by optimizing the alignment we can reduce it by 30% down to 7 million. You can also get detailed summaries for each alignment. So imagine doing this manually or calculate this by hand. It can take some time. Here we have the cost divided by percentage and also the CO2. So especially in Scandinavia, this tool is used a lot. Last year, there was a Norwegian record in planning time, documented by NTNU and SINTEF, which said that the project found the corridor 50% faster than average delivery time, which means that the project can use more time on making decisions, testing different scenarios, and documentation. So the project time won't be 50% faster. You only have more time to increase the quality and other processes in the project. So instead of using the traditional method, using 3.5 years or more, you can find the alignment within much shorter time. So you can calculate and get automatically review of all the results 50% faster, and this is not possible in any other way, was the message from the project team. So you can also have some visualization in Quantm. You can export different reports and also export results to any other design tool. So this is a 10-minute short explanation of Quantm. I would also be happy to share a project with you. So you have the theory from the slides. We will together walk through the main activities and the highlights of the software. We'll add this terrain model, satellite image, start point to the left, right corner we can find the endpoint. Let's say that all alignments have to pass through the waypoint. We have some Norwegian things here, but there is some nature areas in red that we have to avoid. We have an airport. We also need to avoid it. We have some existing railway. We have to cross it. We have some lakes we need to cross by bridge. We have some areas with additional cost because we need to buy out all these buildings. We have some farmland. We have to be inside this corridor. And we can set some other linear costs and some requirements to cut and fill heights before bridge and tunnel. This will be a road project with the geometry of the road, and we also have added our cost and CO2 parameters from the template. So adding all these information within short time, Quantm will calculate the different options. And you will see the alignments with different colors. And we can compare them due to costs, but also due to CO2. So we can see that the cheapest one has a little bit more CO2. So let's go and pick this one with quite low cost and quite low CO2. The alignment is placed on the south side of the airport, avoids area avoid zone and go through the waypoint. And the price is about 800 million. So with Quantm, we are now able to do different kind of optimizations. Maybe we just are going to do a vertical optimization, and we can review that result. We can see we can go down from 832, the black one. We can reduce it to 695. But have a look at the CO2 from 60 to 59. So by doing this optimization, which is about placing the intersection point on right places, avoiding long bridges and tunnels, also minimize the footprint of going through different areas, we are able to find cheaper, shorter, and lower CO2 alignments. 695 and 59, we can do some vertical optimizations and ending up with 641, 56, and 493. don't be so upset about the numbers. The idea is that Quantm will give you this summary that you can documentate what happened, why it happened, why is this alignment so much cheaper than the last one. So we can now see we have the different, how the cost and CO2 is divided into the project. Now you can, for example, export alignments to your design software, or you can do the opposite. You can import also alignments from different software. Sometimes, maybe you're working with CO3D or NovaPoint. Take those alignments into Quantm. One click, you'll have summary. You can compare it with the alignments Quantm have found. So this is a nice exercise and something that is sometimes also required, because it's fast and will give you a lot of information that makes you and your product team and your manager, that make you sure about finding the right option, and you can see and documentate other solutions. So doing this exercise before you go full in and go for the design of one alignment, I would say that this is a fast and nice exercise to do up front. Last thing I want to show you before I'll also go and eat lunch is visualization. Quantm has 3D visualization of these alignments. So I'll drag it into the screen within a few seconds. So the 3D presentation I'll show you will show us a little bit about cut and fill, where it's structures. You can also add cars driving and those kind of things. So we can go to drive-through, enable drive-through, and we can see our 4-lane highway, and we can add a little bit more speed. And then we can also see the GIS areas. Perhaps it's a bit lag for you watching through web, but the point here is to have a visual overview of the project. So by now I think we have gone through the most important parts of Quantm within 20 minutes. If you have any questions or want to contact the Trimble team, please don't hesitate to drop me an email. And by that, I want to thank you for listening and wish you a really nice day.